Hello. The goal for today is to see if we can get this ofxASIO, which is a lightweight wrapping of the ASIO networking code from the Boost library, made specifically as a open framework add-on. And so to add open framework add-ons, typically the process is to add them into the add-ons folder. And we can see that there's a bunch of add-ons that come already with open frameworks. We want to add this as an additional one. So what we're going to do is we're going to right click in the add-ons folder, go to open in terminal. I've got Git installed on my machine, which I'm going to use. And so I'm going to go and grab the HTTPS endpoint for this ofxASIO Git repo. And then at the terminal, I'm going to say git clone. I'm going to paste that in. And we're going to see that we have that in my folder now. I'm now going to go to the openFrameworks project generator. I'm going to go to the project generator itself. Now, I don't believe I can just add this in. But let's try it. So I'm going to say ASIO test, and I'll just try adding it in here, and I'll generate and open this up. See, in the other window, I've got this retargeting projects, because the default project that's made by the project generator just needs to be retargeted to the latest version of the toolset and the Windows SDK. So I click OK for that. That brings me to a project where I have, here's my project itself. There's the ASIO lib. So far, so good. In my project, yeah, okay, let's see what we can do. I'm going to go to, I'll just try it first just to compile this to see if it works. Okay, again, so far so good. And let's go into the ofx.h file. We'll try just including the ofxASIO.h file, and again compiling just to see if everything is working correctly. Again, so far so good. And then I'm just going to copy and paste some code from another project. So into the header file, I'm going to create two thread variables that I can use to set up a TCP/IP client and server thread. And then I'm going to ofxASIO and creating a TCP/IP server, a TCP/IP client, and a Boolean that's called threads running. And what will I do now here? I'll just, again, I'll just copy and paste some code in the setup of my open framework here. I'm going to paste in some code. Here, I'm just setting up two threads. One, which is going to initialize a TCP/IP client trying to connect on localhost, so like on my own machine, to TCP/IP port 5000. Meanwhile, this other thread is spinning up a server on port 5000. And then as long as that thread running variable is set to true, we're going to update both the client and the server. And again, let's just let's save all these files and try running the code. I get this message just saying like, do you want to allow? So this is because this app is trying to make use of the network. So the Windows firewall gets a little paranoid, and I can say, well, this is fine, allow. There's no output, of course, because I haven't asked for any, so I'll close this down again. I do find that when I close it down, I tend to get exceptions that are being thrown. I think this has to do with like the networking trying to sort of continually update. There might be a way of like turning this threads running to false when we shut down the machine. That will probably fix things here. So I'm going to go into ofxASIO exit. Do I have that defined? I don't. So I can define the fact that I want to have an ofxASIO exit. And I will create the definition over here, and then all I will do inside of there is I'll set this dot threads running. I probably don't even need this thing, but this is fine. Since that's a local variable, I can just do this local to this class, as in it was defined right here. And let's see if that fixes the program when things close. So here we're running, close it down, still getting a bit of an issue on exit. Let's see if this is actually just see if that exit is being called. So there's openFrameworks running. Close it down. Exit does get called, but we do have a abort has been called. And that's on the thread. Thread if joinable terminate. I think what I'll need to do, so if when we set this thread running to false, that's going to stop these while loops inside of the thread. The thread's now going to get to the end, and it should end itself, but what's happening is the openFramework app is ending before the thread is ending. So what I need to do is I need to wait for both of those threads. And we can easily block and wait for both of those threads by going to each one of them. So we can go to the client thread and .join. Is that what I called them? Client capital thread? Yeah. And I can go to the server thread. And join just is our way of waiting for these threads. So this function will block until the thread has exited. And now I can run my code. And when I exit out, yay, no crash. And now we can even do a little bit of output. And again, I'm just going to copy and paste some code here into the draw block. And so what I'm going to do is I am going to stream into a string stream some information about the client and the server, and just to check to see if the client and the server are connected. And we'll print out the words true or false for both of them to see if they are connected. And so what we should see now in the output when we run the program is that both the client and the server should be listed as connected. And then we know that we've done a TCP/IP connection. In this case, this is like both the client and the server not only running on the same machine, but running within the same application. We could have these running in separate apps as well. So I'm just going to click play on here. And there we are, client is connected, server said false for a moment, but it updated and now it says true. And so there you go. We are done. We've got ASIO running with openFrameworks. it is just ASIO being wrapped. So we don't use the Boost ASIO code directly. If we look into our ASIO lib, we can sort of see how things are structured. If we go inside of our, we were doing the TCP/IP stuff here, so we can see that in the TCP/IP folder, the root of both the client and the servers, they both inherit from socket. And so if we look at socket.h, you can see that this is a class that internally is making use of the ASIO IO service and a TCP/IP socket. And then for the client and the server, they are both inheriting from socket. The server gets a unique pointer to a TCP/IP acceptor. The client has the TCP/IP address and port that it's going to connect on. So again, we're not interacting directly with ASIO. We have like a really thin wrapper around ASIO. And if you want to see more about how that's implemented, you could dive into the socket.cpp to sort of see how things are happening behind the scenes. You could dive into the client and the server. I guess the last thing I could show you is actually sending messages back and forth. It's not going to be super impressive again, because we're like sending them between a client and a server that are running on the same machine in the same app, but at least we can see that we can send those messages across the TCP/IP connection. So I'm going to make this happen inside of the update here. And so inside of update, I'm going to create what's called a datagram, and that is going to be sort of our unit of message that's being passed between the client and the server and vice versa. So I'm going to set up a datagram. It's going to be a shared pointer. We'll see why in a second, of type ofxASIO datagram. And then we want to call that directly, right? So we have the parentheses directly following make shared. So we're gonna sort of make the shared pointer right then and there and assign that back to datagram here. And then we want to get access to the message that lives within the datagram. And so we're going to get a reference to that message by going to the datagram and getting the message. I want a reference to it because I want to actually change the message that's inside of this datagram. So I'm going to go message, and I'm going to set it, and I'm just going to say hello world. And now I actually have to send that message. And so I'm going to, it doesn't really matter who does the sending, who does the receiving here. I'm going to send from client to server. And so I'm going to go client.send, and I'm going to send my datagram. I should probably only do this if the client is running. Remember, behind the scenes in a thread, we've initialized the client, and we are sort of continually updating the client. And so I should be able to do something like this: if client is connected, and then only send that message if the client is connected. And then I can do something equivalent down below here for the server. So if the server is connected, then we want the server to receive a message, and we'll get it to maybe just print that message out to the screen. Maybe we'll just print it out to the console for debugging purposes. And so does this look correct? Everything looks pretty close. This should be the word string, shouldn't it? No, I'm gonna need to. So if we got a datagram, again, I want to like get access to the message. So I'm gonna get a reference, to the datagram message, and then I can output. I'll just do a cout received, and then I have to go to the message, and I need to get the message string. And that should be enough to handle all of this. And I mentioned earlier that we had to make this as a shared pointer because that's what the send, the client send is expecting. You can see if I hover over send here, it's expecting a shared pointer to an ofxASIO datagram. So let's run this code. In the canvas window, we see both client and server have connected, and over here in the console, we see that we are continually receiving hello world from the client. And that should be enough for now. You could now separate this out into two separate apps, both of those apps using the ofxASIO add-on, and you could have a client running in one, a server running in the other, or you could have some configuration so that you could like have just one app, run it multiple times, and select whether you want the app to be running in client mode or server mode.